Hi everyone. We're going to work on some quadratic regression this time. So the steps are going to be really similar to when we did linear, but I still want to walk through all this. I think it'll be great to work through an example. So at any point, if you're feeling good about this, feel free to go try and answer the questions on your own. But otherwise, I will walk through all the parts here. Hopefully you have the worksheet in front of you, but I do have the different questions pasted in here this time. I got a little smarter about using Desmos and not having to switch back and forth. So your very first problem should be my example problem. We have a data set that gives the number of AIDS cases among people 21 or younger in the US. And I have already gone and copied and pasted that table in. So that's all you have to do is select the entire table and copy and paste it in here. And your scatter plot should immediately show up. So that's our part A. We're done with that. The next part of this, and sorry, the math formatting doesn't come through, but basically the next part of this is to try and use Desmos to eyeball a best fit quadratic model in Vertex form. So let's see, let me move this in here so we can, whoops. Okay, so I know I want a y equals something, so we're just going to start with 1 times x minus something squared plus something. Okay, so if we're trying to find a model in Vertex form, what I'm hoping we've started to really connect with is the fact that the thing that Vertex form gives you very easily is the vertex. So if we're reversing this process, trying to take what we see as a quadratic trend and put it into a formula, I would estimate where you think your vertex should be. So it doesn't have to be exactly on this highest point, but that definitely should be kind of in the ballpark. So I think I actually like the x coordinate of that. So I'm going to say I want the vertex to be at x equals 11, which means in the parentheses you should have x minus 11. Remember the sign change. If you want your vertex at positive 11, you have to have an x minus 11. And then the y value of my vertex, what is this, 40 to 50, 1, 2, 3, 4, 5. So 2000, I think, is my interval. So somewhere around 4200. Oh, wait a minute. 42,000. Okay, liking it better. Okay, so I have a point there, but this looks like absolute nonsense. And what's happening is right now our A value is positive 1, and that's probably a terrible choice. For starters, remember that your A value out in front is what tells you if it opens up or down. So I definitely want a negative, which doesn't look like it made much difference. You might be looking at this and thinking you're looking at a straight line, but what you're looking at is a parabola that's really, really flat compared to our scale. So I don't want my parabola to be nearly as fat, so I'm going to start playing around with this number out in front and say, well, if I want it to be taller and skinnier, I make that number bigger. So there's 10, which doesn't even look close to being steep enough. So I'm going to go 100. Still doesn't even look close. 1000 is actually not bad. That's a little too steep if you watched how that happened. So let's say 900. Oh, 9,000. 900. There we go. And I actually think that's still maybe a little too steep. So I'm going to go 800. I'm just going to play around 7. Ooh, I'm liking that fairly well. Except it seems like it's sort of missing the trend on the right-hand side of the vertex. So I still think I like 11, but I'm going to actually move it down a little bit. Maybe I really do only want, no, 40, 41,000. Maybe I'll move it back a little, 10.5, 10.8. Ooh, I like that one pretty well. Okay, so just play around with this. You only have a couple of these where I ask you to do the eyeball, but I think you actually might get the most learning on this worksheet from those problems just by playing around with the form and saying, okay, well, if I move the H or I move the K or I move the A, what does that do to my graph? So fiddle around, do the best that you can. The next thing we're supposed to do is ask Desmos to create a best fit model in this same form. So now we're going to go in and say, okay, well, now I want my y sub 1s from my table. So this isn't just like variable y, this is specifically the y sub 1s in my table. And I want to model those, so I need a tilde, with an a times x minus h, oh, and it's x sub 1, because I want the x's from my table, squared plus k. And actually, I'm kind of impressed. I did this earlier and I didn't do quite that job with my best fit, the eyeball best fit, but it looks really, really close. And that's kind of what I'm hoping you'll see. They don't have to be perfect. I'm not expecting you to get it perfectly when you do the eyeball best fit. But if you're seeing a pretty big difference between your curve and the other curve, you might want to think about what went wrong. And that's actually one of the questions in part C is reflection. So if your model does look off, is your model the one that's wrong, or is Desmos the one that seems wrong? And can you figure out what's wrong with whichever one? Maybe you didn't type something into Desmos right and it's actually the bad one. Interestingly, if you do the different forms, sometimes one of the forms will do a good job and the other ones do a bad job. I'm not quite sure what's happening behind the scenes. You can play around with that a little bit. Okay, so at this point, you'll be expected to copy and paste this back into your Word document. So you should be typing in equations as you go. But this one, remember, you want to export, which is this little arrow up at the top. So hit that button and then export image. And it should download. So you will, I don't know, if you're in Chrome, it'll show down at the bottom that you downloaded the image. And then you can just copy and paste that into your document as well. Also remember, if you're not happy with the window you're looking at, there's this settings button up towards the top that you can click on. My little record thing's right over the top of it right now, so I can't click on it, but you can set your X-min, X-max. So remember, you can fiddle with that. You can even add some labels, which I would do right now if I could get at it. So remember, the little settings thing right above this plus minus will allow you to type in labels and set your window and so on. Okay, according to your model, when was the number of AIDS cases among people 21 or younger highest, and what was the highest number of cases? So here, I'm just going to, oops, scoot down a little. Should be giving myself little spaces here. And actually, if you want to, you can do this typing. I just put in a quotation and it turns it into a note. So I don't want you to do any work in this case because we were given vertex form. We don't have to do any algebra. If you're in standard form, I expect you to use the x-coordinate of the vertex is negative b over 2a. So you will have to do work on some things, but in this part of this specific problem, I can just look at my numbers from when I found my model. I've got this A equals negative 692.6, H equals 10.83-ish, and K equals 41,099.7. So the H is going to tell me the x-coordinate of my vertex. The minus sign's already built in up above, so it should be just fine. 0.829, so we'll say 0.83. And then the y coordinate, 41,099.7. So that is my vertex. Remember, your horizontal axis, which I couldn't get labels on because of my record buttons, is telling you number of years since 2000. So this is saying towards the end of 2010, we should hit this vertex, this maximum, which I'll show you here. You can actually, if it'll let me select, if you click, it'll try to gravitate towards that point and tell you exactly where it is. So there, I don't know which model it might be. In fact, I do. That's my model. So it's saying the vertex is at 10.8. You can click the little black circle next to it if you want to turn yours off. I could get it from this one as well. 10.829, that's what I'm looking at. So towards the end of 2010, we hit a maximum of 41,099, or you could just say 41,100 if you want to round to the whole people there, cases of AIDS in people 21 and under. So that's the information we're getting from our vertex. Okay, part E, using the data, determine when the number of AIDS cases will decrease to 0 if the trend continues. Okay, so I'm going to show you how to do this in Desmos, but I want to be really clear that on a test, I'll be expecting you to do this by hand. So to do this by hand, you're going to go back up to your equation that you should have typed in. So I'm going to click on my equation up here, but you actually probably should use the one below that's just not typed up. So you would set the equation equal to 0. If number of AIDS cases is on the y-axis, you're going to set y equal to 0 and solve. We're looking for x-intercepts. This is beautifully set up to solve using square roots. The complete the square root part already happened. So just isolate the x minus 10.8 squared, and then you can use that plus or minus trick to get the two answers. Desmos, again, wonderful about these things. You can actually just come over here and click, and it will want to show you those points. Sorry, let me move so I can see both. So I'm seeing that my x-intercepts are at 3.126 and 18.532. So those are going to be years. We're not wondering when the model predicts that the cases would be 0. So that says in 2003 and in middle of 2018 is what we're looking at. So would have just happened. I would say that I don't really like the first one. I find it very unlikely that we were at 0 and then this all happened. But the second one seems to be what this question is asking for. So I don't think we actually did hit 0 in 2018, but according to the model, that data trend would predict that we'd get to 0 cases in 2018. So that's what that's looking for. So we can say when the number of AIDS cases in 2018, we'd expect the number of cases to decrease to 0 if this quadratic trend continued. Probably didn't, because we know we didn't get to 0, but that's what the model's telling us. All right, part F wants a reasonable domain for our model. So we want to just think about what would or would not make sense in this one. I was sort of feeling like it didn't make sense to go back and say there were 0 cases in 2013. For sure, we don't want to go back before this because then it says there's negative cases and that doesn't make sense. So you get to make some judgment calls when you're stating reasonable domain. I would say the lowest cutoff you could use on the left side would be this 3.126. You're definitely stepping into something unreasonable if you get negative cases. If you're feeling like me, like we know it wasn't 0 in 2003, then you could cut it off at 2004. I wouldn't cut it off before that because we actually have data in 2004. So we were looking at years since 2000. So we're going to say starting in 2004, and then this is domain, so we're only talking about the x value, the year part of this. I would say in this one, we want to cut off for sure at this other x-intercept, because again, we're going to drop down to negative cases, which absolutely is nonsense. So we could say 18.53, somehow I clicked off of it, 532. I don't want you to assume that your x-intercepts are always going to set the domain. Sometimes you don't want to go that far. Sometimes negative outputs make perfectly good sense. So I want you to think about it, and I want you to justify your answer for me. So I want you to explain what you were thinking. I want you to say negative cases of AIDS doesn't make sense. So I for sure have to cut this off at the 3 point whatever and the 18.53. If you're thinking we know we weren't at 0 in 2003, then you could cut it off at 4 and just explain that. I'm more interested in what you were thinking about than if you understood every detail of some of these problems. We're not experts on all of these things, so we're just trying to make some sense out of our model. Okay, last but not least, we want to find the average rate of change from y equals 2 to y equals 8 and explain its meaning in the context of this problem. So those numbers might not make sense if you're just looking at what I have here, but on your worksheet, our variables were actually supposed to be y for year is what would be on the horizontal, the x-axis, and then what is this one, AIDS cases? I think I did C for cases on the vertical axis. So you will want to try and use those answers when you type up equations, but I didn't type them up here, so I didn't switch. So this is the x-axis, year 2 to year 8. So average rate of change, remember, it's just a formula. We're going to try and calculate slope. Here, I actually don't know what Desmos will do if I just give it a calculation, so let's try. So we want to know, oh, it's mad about nothing in parentheses, from year 2 to year 8. So we know that's over a 6-year period. So the bottom of AROC would be 8 minus 2, which is 6. And the top would be our number of cases in 2008. Let me see if I can just get the model here. Hold on. If you click on the little green dots, that'll turn that off. So I'm just looking at the model now. I'm interested in 2008. Let's see if I can get it. Sometimes it's tricky. So if you click and hold, you can move your cursor around. So 35,555.77. I'm going to round to, well, no, I'll keep the decimals for now. So 35,555.7. 35,555.7. And then we want to subtract the number of cases in 2002. Oh, you know what? I'm going to change that to a 4. I don't know if I caught it there, but I don't really want to go into the negative here either. I was definitely going for this 4. So I will change it on the worksheet if it's wrong now. So let's see. If I want to figure out at 4, again, sometimes it's a little finicky, but there we go. 8,797.582. 8,797.582. Hopefully I didn't do anything dyslexic on those. Ooh, and it is calculating for me. Beautiful. I haven't tried to just calculate here. So we're getting 4,459.7-ish. And we want to explain what that means in the context of this problem. So remember, on your vertical axis, you have what do we have? Number of cases of AIDS in people under 21, and on your horizontal axis is years. So that's change in number of cases per 1 year. So if I was going to explain that, I would say between, oh, hold on, 4 and 8, I got to change this. So it was really only 4 years, so 6,689.5. Between 2004 and 2008, the number of diagnoses of AIDS in people under 21 was increasing by an average of 6,689.5 new cases per year. So that's what I would say is going on in this one. Okay, so sorry for a long video. I just wanted to do the whole shebang so you could see all of it. And then the rest of the problems just ask you to do various pieces of this, but I think I gave you an example of everything you'll be asked about. Thanks for watching.